will be our perimeter there, right? Then we move on to the B part, which says find the area of the face ABC of the coin, giving your answer in terms of pi and √3. So for this one, we are going, let me just about this one, like so. So for us to get the area of face ABC, we are going to consider a diagram like this, right? And what I'm going to do here is I'm going to get the area of this space that I'm shading, right? That's the area that I'm going to calculate. Then I'm going to calculate this area right here and this area right there, and I add, and I know this area is equal to this one. So I'm going to say area of the arc half, not area of the arc rather, area of a sector half r squared theta. Then I get, because I know this is a third pi like this, I know this is 2 for my r, so I'm going to get the area of this sector right there. Then for me to get the area of this part, I'm going to say area of the sector minus area of the triangle which is inside, and I'm going to get area of the triangle by saying half AB sine theta. Then once I get the area of this part, I multiply it by 2 to cover these, then I add to the area of this sector, so it will be this area and this area and the shaded area. That's how I'm going to go about it. So like I said, we are going to say area of a sector is given by half r squared theta, and we know half our r is 2 squared, our theta is a third pi, like that, right? And punching this in, we're going to get 2/3 pi, right? That's the area of that sector, right? This one, the shaded one, right? Then area of this part that I'm shading in blue, right? We are going to say area of a sector minus area of that triangle. So area for that triangle is half AB sine theta, which is half A and B, that's like 2 times 2 sine a third pi. Make sure your calculator is in radians, and punching this in, you get √3, right? So for the area of this part, we are going to say this minus that, so it's 2/3 pi minus √3, and we know we need that for these two unshaded parts, so we're going to multiply it by 2. So this is going to be 4/3 pi minus 2√3, like that. That's the area of these two unshaded parts. So we're going to add that to the area of the whole shaded thing. So that will be our 2/3 pi plus 4/3 pi minus 2√3. And these two are going to give us, they're going to give us what? That's 2/3 plus 1 in the third, 2 pi minus 2√3. And that's the area that we were being asked to calculate right there. I hope I made that clear enough. So we move on to the fifth question, which reads, the first, second, and third terms of a geometric progression are sine theta. So the fifth question is saying the first, second, and third terms of a geometric progression are sine theta, cos theta, and 2 minus sine theta respectively, where theta radians is an acute angle, and we're being asked to find the value of theta. So we know that for a geometric progression, there has to be a constant common ratio, and we get that by saying cos theta, which is the second, over the first, right? And it's constant, meaning that 2 minus sine theta over cos theta will give us the same ratio. So cos theta over sine theta should be equal to 2 minus sine theta over cos theta. And cross multiplying, we get cos squared theta is equals to 2 sine theta minus sine squared theta. Right? Then we know that cos squared theta is 1 minus sine squared theta is equals to 2 sine theta minus 2 sine squared theta. Right? No, this is not 2 sine squared theta. This is just sine squared theta. This is minus sine squared theta. And minus sine squared theta and minus sine squared theta will cancel out. Because when we take either one of them to either sides, they will cancel out. So 1 is equals to 2 sine theta. Dividing by 2 both sides, we get our sine theta equaling to half. So with that, we know theta is equals to arc sine or sine inverse of half. Theta is equals to 1 over 6 pi. That's the value for theta there. Right? Then we move on to part B. It says, using this value of theta, find the sum of the first 10 terms of the progression. Give the answer in the form b over root of c minus 1, where b and c are integers to be found. So we're going to be using this value, the one we just got. Theta is equals to 1 over 6 pi. Right? So punching that value in, we're going to see that is sine theta, right? Cos theta, then 2 minus sine theta. So we're going to be substituting theta for this value. So sine 1 over 6 pi is half, and cos 1 over 6 pi is root of 3 over 2. 2 minus sine 1 over 6 pi should give us 3 over 2. So this is the first, the second, and the third terms. Right? So r is equals to root 3 over 2 divided by half. Right? So this comes down to root 3 over 2 times 2 over 1, which gives us r to be root 3. And the first term, a, is what? Is half. Right? And so we're going to be using the formula sum of 10 terms is equals to a bracket 1 minus r to the power n over 1 minus r. Right? Substituting the values we have, it's half 1 minus r. Okay, we're substituting it now, so it should be in place of r, it's now root 3 to the power 10 over 1 minus root 3. And this expression simplifies to 121 over root 3 minus 1, which is in this form, b over root c minus 1. Right? Then we move on to the sixth question. The equation of a curve is y is equals to x squared minus 8x plus 5. And we're being asked to get the coordinates of the minimum point of the curve. And for us to get that, we just express this x squared minus 8x plus 5 in the completed square form. Right? So then we write x squared minus 8x minus 8 x plus 5. In completed square, it will be x minus half of this, which is 4 squared, plus 5 minus the square of this, which is 16. That will be x minus 4 squared minus 11. So minus this will be our x coordinate and this will be our y coordinate. So the coordinate of the minimum point is minus this, which is 4, and minus 11. And these are the coordinates of the minimum point of the curve. And how do we know that it's minimum? We look at the coefficient of x squared. If the coefficient of x squared is positive, it means the graph is like this. And if it's negative, it means the graph is like this and it has a maximum turning point. So if you look at this expression, you can see that the coefficient of x squared there is 1 and it's positive. So we have a minimum point. That's why they didn't say the turning point of the curve. They went straight and said the minimum point of the curve. Alright? And it's 411, minus 11. Then 6b says the curve is stretched by a factor of 2 parallel to the y-axis and then translated by 4,1, by a vector 4,1. Find the coordinates of the minimum point for the transformed curve. From part A, we know that our coordinates for the minimum point 4 and minus 11, making one coordinate. So the minimum point is 4 minus 11, right? And the curve is stretched by a factor 2 parallel to the y-axis, meaning it's only affecting the y-axis. So we're going to multiply the y-coordinate by 2. And we get 4 minus 22, right? This is after the stretch by factor 2 parallel to the y-axis, right? And it is then translated by 4,1, right? Meaning to the x-coordinate, we're going to add 4. That's 4 plus this 4, giving us 8. And to the y-coordinate, which is minus 22, we're going to add 1 to get minus 21. So this will be the resulting coordinate of the minimum point of the transformed curve. Then part C says, find the equation of the transformed curve. Give the answer in the form y equals ax squared plus bx plus c, where a, b, and c are integers to be found. So for this one, I'm going to try and write it in completed square form. Remember how we got this from the completed square form? I'm going to reverse this new coordinate to this, right? So if these are the coordinates, the x and y coordinate, it means the completed square form was looking like x minus 8 squared and minus 21, right? For us to get 8 and minus 21 as our coordinates. But since we know that the equation, the original equation was stretched by a factor 2 parallel to the x, to the y, so there is a 2 here. So this is the equation of the new one, but we need to express it like this, right? So just us expanding 2x minus 8, x minus 8 minus 21. So that's 2x squared minus 32x plus 64 minus 21. That's 2x squared minus 64x plus 2 times 64 is 128. 64 times 2, 128 minus 21, resulting in 2x squared minus 64x plus 107, right? That's the